So it's like a crossword puzzle. If you want to just write the words on a Word document and hand it in on e-learning, that's fine. I was trying to make it fun. I don't know. If you want, I'm here until Thursday morning. I'm here until about noon on Thursday. Okay. So if you want to fill it out and bring it to class Wednesday, lab Wednesday afternoon, or even anytime Wednesday, put it under my door in my office. Or Thursday, I'll be in the lab until about noon. Okay. Otherwise, you're gonna have to submit it through e-learning if e-learning is working by Thursday. No clue. I think it said our ETA is unknown. Is that what y'all thought? That's, yeah, and I think did we get an email saying no? Okay, we got an email saying like something like ETA for being fixed. It was like unknown. Like, yay. So I'm glad we got these printed. For homework 3, and I'll go over this again towards the end. Homework 3 is actually going to be the flow chart for lab assignment 4. Okay. Try to get that done before you either come to lab or try to start programming. It's going to help. Okay. So the homework assignment goes with the actual program. Okay. For lab. Does that make sense? Okay. Y'all want to hear something even scarier? Our midterm Monday. We're halfway done. Is that scary to anyone else, or this is me? I feel that, right? Monday is going to be our midterm. So I don't like the e-learning platform, so I will bring printed copies if you would like to use a printed copy. We can do it in here. We'll start at 8 o'clock. You'll have till 9:30. It's going to be the same amount of time as if you were to take it online. There's a 90-minute timer on the online thing. If you do it online, you have to use the Proctor 3. Okay. So honestly, I mean, it might just be easier to make sure you bring a pen and a pencil, or something like that. Does that make sense? It's all majority of it is multiple choice, true and false. There's a few questions at the end where you have to write in some words. The crossword puzzle is going to help with some of those definitions. Okay, that's kind of why I did that. Okay. Hopefully that'll get you through kind of where we need to go. Wednesday, we'll do like a quick review of everything that it's over. Okay. There's no like create a program for the midterm. Okay. There are though like snippets where it's like read through this. So for example, I think some of the questions are like, it'll give you a for loop and it'll say, what does this do? It'll give you a couple options, for numbers or for text or whatever. But you're not going to have to write like we do in lab, Boyd may, write a program from scratch, not for the midterm. Okay. Does that make sense? Okay. Okay, cool. I'm doing it to know what you know, not to make y'all fail. I don't know. What do you guys say about midterms? Just to make you fail, just to aggravate you, just to no. Okay. No, I just want to know how far we are with the concepts. A lot of it is even more background information and like why something happens, as opposed to like write this code, like I said. Okay. Makes sense. Okay, questions, comments, concerns up to now, other than the fact that e-learning is not working?
I'm sorry I'm late, and can we use like the sheet that you gave us?
Yes. Yeah. So if you want to bring in that 1 page, that card that I gave you in the plastic, and if you didn't get it, let me know. I've got some in my office. You don't have it? Okay. Does anybody else not have it? Okay. Do you have time to come by my office today? Are you going to the game today? Okay. If I don't see you this afternoon, I'll bring it to the 5:30 game. Are you feeling better? Okay. And yeah, guys, if you're sick, please don't come to class. I'm just telling you, please keep your germs to yourselves. Because apparently there's a lot of ick going around school right now. We've got a few COVID icks, and we've got a few. Is that you, William? William, no escuchar. That just say he doesn't listen to me? Was that kind of ish? Does he doesn't listen to me? Okay, cool. I know Taylor wasn't feeling well in the last week. I'm not feeling well this weekend. So just there's a lot of it going around. So please do self-care first. Okay. You can get caught up in here. Okay. Does that make sense? Please. Okay. I need to get y'all's letter out. So some people are flying to places this weekend. They're bougie. I'm not sure I want to be on a plane with all you volleyball people. That's just me. I'm not sure I want to be on a plane with all you people either, so don't even go there. Okay, so today we're going to be doing a few new concepts. I have no idea if my marker even works today. Yeah, iffy. Okay. We're going to talk about constants. This dips a little bit into chapter 6, but I'm using it for our lab, so I wanted to introduce you to it. The constant part is not going to be on the midterm. We're going to use it, so I'm going to go ahead and explain it. Switch, which is our last kind of decision. Break, types of iterations, and then we're just going to do kind of what we've talked about so far. Okay. Once we get through with today's lecture, most of the stuff from here on out is putting all of these little pieces together in the way that we need to in order to make a program. Okay. And how we make code reusable and things like that. Okay. But our building blocks are going to kind of be done after today. Okay. So I think when I go back to my office, I'm going to try and put the PowerPoint up in Discord because e-learning's broken. So if you're in Discord, please check there. If you're not in Discord, either go add yourself to the channel. If you don't know what Discord is, you can come see me. Okay, but I'm going to try and get you that. Maybe I'll even, well, see. I was going to say I'll email it to you, but usually I email through e-learning because it says email the roster. You know what I mean? So I don't I'll throw it in Discord. Okay. So if you would like to have it before e-learning decides to behave, look there. Okay. In C, we have something called a constant, and we call it a symbolic constant. Okay. It'll look like, does this look like anything that we have done before? What do we have here that looks familiar? Does that kind of look familiar? Yeah. Okay. Where we usually put the statement that we use so far with that hashtag? At the very, very, very beginning. Okay. The reason why we do that is the compiler actually sees that as a preprocessor. Okay, it's a function that the preprocessor is going to do it. So anything with the hashtag is going to do absolutely first, and then it's going to go down the rest of the code. Okay. So ours that we know is the hashtag include. Oh, wow. That worked out for like 0.3 seconds, right? Okay. Those go first, then you can do your hashtag define. Okay. A constant is exactly what it sounds like. So instead of a variable, which is something that can change value, a constant will never change. Okay. Once it has a value, it's always that value. Okay. Programming rule of thumb, constants are going to be completely capitalized. Okay. So if you're reading code and you see something that is completely capitalized, you know it's a constant. Okay. So your preprocessor is going to replace wherever it sees the word size with the number 5 in the program before it compiles. That's why it's a preprocessor. Okay. It's going to make your programs easier to read and easier to modify. If for some reason I am looping through the number of students in a class several times, so say in my program, I want to know how many students are looping through it 8 times, okay? I either put the number of students 8 times, right? Or I can use the constant, like number students. Okay. So how is this going to help me? Well, let's say today I have 15. Okay. That 15 is in 8 different places, right? What happens if 3 people drop? I now have 12. Okay. Is it easier to go and find the 8 different places that I use the number 15, or to update it here from 15 to 12? One time. Which one's easier?
Yeah.
One time, right? Because this would say hashtag define and then 15, and then all I do is come in my code and change it to a, wow, that lasted like almost 2 seconds, a 12, right? So it's going to make your code a little easier to understand and much easier to modify if going down the road. Okay. You modify it once, it modifies it in every place that you've used it. Okay. Helps for readability. Because if I say for 1 to 15 everywhere, do I really know what that 15 means? Maybe, maybe not, right? If I put from 1 to number students, do I know what that means? It's a lot clearer, right? So again, these hashtag words, no commands, that's it. The hashtag do not have the semicolon, okay? When we do the hashtag include with the pointy bracket, we never put the semicolon again, right? We do not do that here either. Okay. Okay, yeah, your constants are not variables. You're never going to change them within the program. Okay, it's set once, used multiple times. Okay, so that's basically a lot of words to say that. Okay, and like I said, that's not on the midterm, that's just going to be in your lab. So I wanted to introduce you. Wow, red's a terrible color on a whiteboard, huh? So I want to introduce you to it so that when you see it, you're not like, what is that? Okay. So what we're doing in our lab is there are a few constants at the top that are TV stations. Okay. I think I put CBS, ABC, NBC, and I put the number that goes with it. Okay. You can add more if you'd like. Okay. You're going to do a loop and go from 1 to whatever. And when the number equals one of those radio stations or TV stations, you're going to print out the TV station name. Okay. So again, you can put those constants at the top. Okay, and make it really quick. Good morning. Okay, break statement. Break is another one of your keywords in C. Okay, and we're going to talk about break and continue. Okay, yeah, sorry about that. We're going to use them to alter this control. What 3 ways do we have control? Sequential, decision, and loop, repetition, right? Those are our 3. And there may or may not be a question on your midterm on what those 3 are, FYI. Okay. If you're in either a decision or a loop and you want to somehow manipulate it to get out, you can. Okay. We're going to use this break or continue. Okay. So break, we're going to put it into a loop or a switch. And what that's going to do is it's going to immediately leave whatever it's in. Okay. So if I'm in a loop and an error occurs, we want to stop being in that loop, right? I know a bunch of us were playing with errors in lab. I remember William did it on purpose, and I think, did you do it on accident? No, I think it was Ari did it on accident, where you had all those enters, you got in that infinite loop in lab. Fernando, was it you? Oh. You guys are the same person, sorry. Anyway. If you have a specific condition, you can tell it to get out of that loop if something happens, okay? So, common uses of breaker to escape early from a loop or skip the remainder of a switch. We're gonna look at a switch here in a minute. A switch is a multi-case decision, okay? So if is a single, if else is a double, a switch is a multi, okay? In a switch, it will go and check every single one of your conditions. If you've already met your true condition, you might as well get out of the loop, right? So that's where we can use our break. Okay, so using our break in a for. Okay, so here's some code. We're gonna loop 10 times. Ooh, I don't know, beginning of my thing. Okay, we're gonna loop 10 times. If X is equal to 5, remember double equal sign means comparison, not assignment, right? Single is assignment. You remember that? If I say X equals 5, it makes X equals 5. If I say X equals 5, it says X equal to 5, okay? Terminate the loop, okay? So if it gets to 5, it's gonna kick out. Okay, so break. That's all it is, break. Lowercase b, break. And then it will print f the number broke out of the loop early at X equals something. So what is the output of this one gonna look like? So this output is gonna go 1, is X equal to 1, or is 1 equal to 5? No. It's gonna print 1. Okay. Add 1, so we're at 2. Is 2 equal to 5? No. It's gonna print 2. 3, is 3 equal to 5? No. 4, is 4 equal to 5? No, so it prints 4. Comes back up 5. Is 5 equal to 5? Yes. So it's going to break. The break is going to take it outside of your for loop. Okay. So your for loop ends here at 14. Okay. So your break is going to put it at 15. Okay. The loop is done. We don't go backwards, right? We go forwards. Okay. So then it's going to print new line, broke out of the loop at X equals 5. Okay. Does that make sense? The break. Okay. Another thing I want to show you in here, we've got a for loop. And what's inside our for loop? An if. Okay. Remember, we talked about what we call nesting these things, putting them inside of each other, right? To do what we want it to do. Because in the end, we can only do those 3 things: sequential, decision, or repeat. That's all we can do. Okay. So here I've got a repeat, and I make a decision in my repeat, which tells me what to do for my next statement. Does that make sense? So continue. Kind of the opposite of a break. Okay. Again, we're in a loop, skips the remaining statements in that control statement and performs the next iteration. Okay. So there's the difference. You stay in the loop, but you basically reset the loop without doing anything after that continue. Okay. So in a while and do while statement, the loop continuation test is evaluated immediately after the continue statement. Okay. Before statement, the increment expression executes, then the loop condition test. So let's go back up to, oh, there we go. Okay. Same code, right? What's the difference? Okay. Instead of break, it says continue, right? Everything else is the same. Okay. So there's my output. There we go. So 1 equal to 5, no, it prints 1. So let's pretend we're all the way up here at 5, okay? Is 5 equal to 5? Yes, right? So I continue, which means I go down to the end of the loop, and I come back up to 6. So do I ever print the number 5? No. Do you see how that works? This print is in the for loop. Okay? When you hit continue, it skips everything below and goes right back to the beginning of the for. Okay? So it will never print the number 5. Okay? At that point, it's 6. Is 6 equal to 5? No. 7, 8, 9, and 10. Okay? Then it stops. You just continue to skip printing the value 5. Okay? So the biggest difference, what happened with the break? Right? It stopped at 4. At 5, it came out and went to 13 here. With continue, it skips 11, but goes back up to 6. So you end up with the 6, 7, 8, 9, 10. Do you see the difference? Okay. Now, some people don't like break and continue. I don't really like break and continue. It's out there. You can do it in other ways. You can use it. You don't have to use it. Except for our lab this week when I tell you you have to use them. Okay. You can do the same thing with your ifs and whens and whiles and do's and things like that. Okay. Remember, this is not concrete, black and white, right? Programming is very gray. Okay. So the biggest reason to use the break and continue is for performance. Okay. We're not worried about performance in this class. Okay. And figuring out which you would rather have, a performance or the ease of reuse, right? So if you've got a bunch of loops and you want to break after you find the value, but you're going through 100 things and you find it at number 2, you really want to check 3 through 100, right? Because what is that doing? That's just taking time and resources. Okay, that's when you can use a break or a continue. Okay, if you want to print a text without using the word is, you can read each word, and if the word equals is, don't print it out and then print a whole document without using the word is. Okay, these are silly examples, but I'm just trying to show you how it's a processing thing, right? So again, performance intensive. First, make it simple, then make it fast, but only if necessary. Okay. When we're looking at the breaks and continues, we're looking at much larger programs. I'm sure like your operating system uses it, right? A lot bigger of a program. Little programs that we're writing in class, not so much. Okay. So unless I explicitly say you have to use it, you don't have to use it. Okay. Okay. So the reason why we went into the breaks and the continues is because of the switch. And I'm not going to lie, I'm not a fan of switch either. You can do a switch with if else's. You don't need to use what they call a switch. But, okay, it is a multiple selection statement. So instead of saying if, else if, else if, else if, else if, right? You can just say switch. I think, I know I'm going to pick the wrong one again. It was either Ari or Fernando. We were talking about like a lot of them together. Do you remember? Was it it was one of you guys, wasn't it? In lab, you're like, what if you have a whole lot of choices to make? That was okay. That's what I thought. Okay, this might be a better way, but else if still works. Okay. It's called a multiple selection. If is a single, because you say if something happens, do something. If else is a double, because if something, otherwise do something else, we're doing two things, right? A switch takes us into n number, whatever we want, 10, 50, 100, doesn't matter, okay? It's a series of labels and then actions. Okay, so let's take a look at what it looks for. Okay, so here, this is our normal stuff, so I just left it down here at the bottom. Again, I will put this up in Discord. I will try to get it emailed to everybody. If you don't get an email from me by like later tonight, email me and ask for the PowerPoint. How's that? Will that work? Okay. Here's my switch. This is really what I want us to look at, is starting on line 20 over here. Okay, I did put the whole program just so you guys can see. Here we've got my int void main. I've got some variables that I'm defining. I've got these say they're printfs. So printfs and an integer. Okay. So what we are doing is we are counting the number of grades within a class. How many A's, how many B's, how many C's. Okay, that's what we're doing. So while, and don't get cut up on 7, while I still have grades, okay, just go there. While I still have grades that I'm counting, I'm going to go into the switch to determine which grade was input. So you say switch and you give it the variable you want to look at. Okay. So after that, you have the words case. Okay. So the words switch and the word case are both keywords, which means we can't make them variables, right? They have to be, they're used as commands. Okay. So switch, variable name. Okay. Case, capital A, case, lowercase a. Okay. So what you have in there is the word case and what you think it's going to equal. Okay. Followed by a colon, not a semicolon. Okay. For your switch, your semicolon is going to be at the end of your actual statements. Okay. At the end of your case is a colon, the double dot. Okay. An error is making that a semicolon, letting you know. Okay. So if is basically what it's saying, right? If my grade is a capital A on 21 or a lowercase a on 22, add 1 to the count of A. Because I named my variables A count, B count, C count, D count, F count. How many A's, how many B's, how many C's, how many D's, how many F's? Yeah. Okay. Add 1. Okay. Then I have this lovely break number, break word. Okay. So where's that going to go now? It's going to come out of that switch. Okay. Because it found its match. Okay. You use break a lot in these cases because here I've got A, B, C, D, F, uppercase, lowercase. So I've got 10. Okay. So I'm checking 10 different conditions in here. Okay. Again, remember performance. Could I leave that break off and just keep on checking? Sure. Right. But if I've already found where it belongs, I can just break out of it, right? It's just going to ignore everything below it. If I have a capital B or lowercase b, it adds to the B. C, D, F. Okay. Now, most of the time in a case, you've got this thing that says default. Okay. Default means if it's none of these things that I've said it is, what do I do with it? Okay. So it's a catch-all. Okay. So say someone puts in a Q. Right? Where does that go? It's going to go into this default. Incorrect letter grade entered. Okay. A lot of times in a switch statement, that default is going to be your error message. Right? Please enter in the number 1, 2, 3, or 4. You know what someone's going to enter? An exclamation point. Or a B. Why? Because humans are stupid. Okay. So what happens with that? We don't want it to cause errors, right? What is the most frustrating thing as a user when you're trying to work a program? When it just blows up, right? Welcome to e-learning, right? Is that not the most frustrating thing? Okay. As programmers, we want to try, we're going to get into exception handling going forward, but keep in mind the user. Okay. Put yourself in their shoes. Okay. We want to, if something goes wrong, we want to bow out gracefully and say, my bad, I'm sorry. Here you go. Keep working. Right. You don't just want it to like blue screen of death. Right. Okay, so most of the times your default will be your error catching, okay? Then you end your switch and you end your while, okay? Your switch does have your curly bracket for your block. That's where all your cases go, and your default goes in there as well. Okay? So remember, we're putting things together. So we've got a loop on 17, and what's inside the loop on 20? A multi-selection or a decision, multi-decision. Okay? So here we've got a loop with another decision inside of it. Okay? We're nesting those together. Does this make sense? Okay. Again, we're programmers, we're lazy. So instead of writing, we could totally write if grade equals capital A or lowercase a count plus plus. Else if grade equals capital B or equals lowercase b count plus plus. Else if, okay, it does the same thing. A little bit less to type doing it this way, a little bit cleaner to see what's going on. But do you have to do it this way? No. Unless I tell you to do it that way in your lab. Yeah, does that make sense? Like I said, I am not a fan of this. I'm not even gonna play. I'm not a fan of cases. I just feel like if you have that many decisions to make, figure out something else. You know what I mean? But that's just me. Okay. So your keyword is switch, followed by your controlling expression, which is going to be that variable. What are you looking at? Okay. In parentheses. Okay. That value, whatever that variable value is at that point in time, is compared to everything that's after the word case. Okay. When it matches, it does whatever it says. Okay. A break is going to exit that switch. So it doesn't go through the rest of the cases and it doesn't end up in that default. Without a break, the cases will start to run together and it might actually go into your default. And it's called fall through because you just fall through the case statements, okay, without actually touching them. Okay. Again, something that's out there, I'm not a fan of, like I said. Okay. Your default case. So if no match occurs, the default case then executes, like we had at the very bottom. Okay. Always include a default case. Do you have to have it? No, it's good programming to have it. Okay. Otherwise, values not explicitly tested will be ignored. Okay. Again, phone system. Please select 1 to connect to the pharmacist, 2 to connect to CVS, right? What if I push a star? Do you want it to just hang up on you? No, right? Because that's kind of what'll happen. It'll just ignore you, okay? Although the case clauses in the default case can occur in any order, usually what we do is the most frequently accessed goes at the top, okay? So if I have like a 90% chance of being an A, I'm gonna put that A at the top, okay? That wasn't necessarily A, B, C, D, F because that's how we look at order, okay? It makes sense for that case, but if you're doing something, you want to put whatever you expect to be the answer the most at the top. We're saving processing speed that way, right? Because as soon as it finds its match, what does it do? It kicks out, right, with that break. So if you put the most oftenly used, I don't think that's a word. When you use most often, like, you're like, I'm not playing that anymore. If you put the one that you use most often at the top of that switch, it'll match it real quick and just kick out of the rest. Does that make sense? Okay, again, that's good programming technique. That's not a hard and fast rule. Okay, again, that's what's going to separate the professional programmers from your amateurs. Okay. You're saving a little bit of processing speed. Okay, so what does this sucker look like in a flow chart? Well, it's kind of a hot mess express. Okay, each one of your cases is going to be that rhombus or that diamond shape that we've gone through when we do any kind of decision making, right? We use this for an if, right? And an if else, we're going to use it for a case. Okay. You're going to go in case A, I'm going to do these things. Case B, I'm going to do these things. Break. Your break is going to bring you back down to the bottom. Okay. So it looks just like an if or an if else with your diamonds. Okay. Bless you. Okay. So when we talk about iteration or looping, most programs are going to do it in some way, shape, or form, right? There are very, very, very few programs out there that's just going to do something and then stop. Okay. Most programs are going to have a loop in some way, shape, or form. Okay. A loop repeatedly executes statements while some loop continuation condition remains true. You cannot forget that variable that has to change. Remember in the while and the do while, you have to change that variable somewhere in that loop. What happens if you don't? You're stuck in that loop forever, right? If you played with lab, you just got a full screen of entering the number and it just kept going, right? Counter-controlled iteration. Which one is counter-controlled? Which one uses a number to count through? 4. Yes. Okay. 4 uses a control variable, right? You say 4, I equals 0, I less than 12, I plus plus, right? That's your control variable. You count through the loop. Okay, you're using that number to count and step. Remember, 4 is used when you know how many there are. Okay. When the correct number of iterations have been completed, the loop terminates. It's not based on something changing in there, it's based on the number of times. Okay. Control the iteration of a precise iteration number is known ahead of time by using your 4. Sentinel is, so they call the sentinel value what's going to halt your loop. Okay, so whatever is going to stop your loop is your sentinel value. Okay, so let's go over all of our flow charts that we know. Okay, sequence, just one right after the other, right? That's the easy peasy one, right? Everyone knows that one. Okay. I clicked on something. Y'all, it's hard being me. Not like this doesn't matter. There we go. Okay, let's try that again. Okay. Selection. So what do our flowcharts look like if we are making a selection? Okay. That is our diamond, right? If statement is a single selection because there's only one branch that goes off. God bless you. Okay. If else, if it's true, do one thing, otherwise do something else. There's 2 blocks. Double selection. Okay. And now we have our lovely multiple selection, right? Multiple diamonds. Okay. On the other hand, we've got our repetition. Okay. It's going to give us that loop. We're still using that diamond, right? But this is what's going to give us our loop, right? So comes here first, while, do something, while, do something, while, do something, okay? A do while. You're going to do something first and then check it. Come back up, do it again, then check it after. Remember, checks first or checks last. Only difference between while and do while. And then your 4, in your diamond, you're going to put 4 equals I equals 1 to 10, do something, okay? Increment, and then loop back around, okay? They're very, very similar, okay? So, quick review of everything we've done so far. 3 types of control. Sequence, selection, iteration, or loop, okay? Or just selection or decision, okay? Those are the only 3 things we can do in a program. Okay, you have nothing else to do. Now it's how you put those together that's going to make your program do what you want it to do. Okay. Oh, bless my heart. I did it again. Look, I'm blessing my own heart. Dun, 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 dun. Here we go. Okay. Your selection is implemented in one of three ways: if, else, and switch. Single, double, multiple. Okay. Straightforward to prove that the simple if statement is sufficient to provide any form of selection, right? You're saying, hey, if it's blue, do this. If it's green, do that. No big deal. Okay. Everything can be done with an if else. I'm gonna die up here. That can be done with a switch. Okay. How you prefer. Whoops. Okay. Your iteration, one of three ways. We now know three different ways. Do and do while. Did I say four? Not three. Three ways. We like number three. Okay. For, do, and do while. Okay. Again, you can interchange all three of them. Okay. Everything can be done with a do while. Even something with a for. If I know how many there are, I can make it into a do or while or do while. Okay. They all three are completely interchangeable. Okay, so program control only one of three ways in C, right? I just can't say this enough. Selection, decision, sequence, selection or decision, iteration or loop. Okay. When you combine them, we're calling them nesting. Y'all know those like Russian nesting dolls, right? You've got a doll inside of a doll, inside of a doll, inside of a doll. That's what we're doing. So we're calling it nesting. We're putting an if inside of a while, inside of a do. Okay. We're just putting things inside of each other. Okay. So today was kind of short, but now we're done with the control of the program. We have all the building blocks we need to do whatever we need to do. Okay. Now we're going to get a little fancy with how we do things. Okay. We went through constants just a little bit. We talked about switch, break, and continue, these types of iterations, and we did the review. Okay. You need to get really comfortable using all of these different types of statements. But like I said, what is there? 3 selection and 3 loop. That's it. Right? There's only 6. Okay. So remember, homework 3 is related to lab 4. Okay. So do homework 3 first. Again, I'm going to try to email out the PowerPoint, and I'm going to try and remember to download the labs and the links to GitHub and all that stuff. I'm going to try and email all that out today. Okay. So that way we don't have to wait on e-learning. Okay. Does that make sense? Okay. And what I'll probably do is download the video to this, and I'll put that link in there as well, and just try to give it to as many people as I can. If you don't get it, anything from me by tomorrow, email me. Okay. So work on homework 3 before coming to lab. It's going to help. I promise. Okay. 4 is in the handout. If you would like to write on it and hand it to me, remember in class Wednesday, under my door Wednesday afternoon, and I'm here till about noon on Thursday. Otherwise, you're going to have to either take a picture of it and scan it, or type out the words 1, 2, 3, 4, 5, the answers on like a Word document and submit it into e-learning. So we're hoping e-learning is working better. Okay. Wednesday, we're going to start talking about functions. Okay. So that'll be fun. Remember, midterm a week from today. Y'all feel comfortable with what we've done? Kind of, sort of. You guys have been doing pretty good in lab. We've been having fun, huh? So remember, in lab, I'm in person Wednesday afternoon at 1 o'clock and Thursday morning at 9 a.m. Okay. So if you'd like to come see me in person, come during one of those days. Don't worry about doing the reservation system. If I need to open up the other computer lab, I'll do it. It's just with the domain things, I'm going to have to log you. It's just, that's still not working either. Okay. If you would like to come to lab, can you get logged in the lab now? Was it? Okay, last time, because as of last week, we could not. If you would like to bring your own laptop, feel free to come to lab. Okay, a lot of people do bring their own laptop. we are able to plug into the hardwire internet in the lab. So you are much, much faster in there than you're gonna be on the Wi-Fi. Okay, so even if you want to come to just use the Ethernet cord, have at it, okay? Another thing, when we're in lab, we usually do talk about it and we kind of write a solution on the board and then everyone kind of types it out. So not everyone's like on their actual own, right? We kind of make it a group project when we're in lab. Does that make sense? Questions, comments, concerns? No? Okay, remember, if you're sick, please don't come to class. I love you, but I don't want your germ. Cool? Okay. See y'all on Wednesday.